Okay, so in this question, we need to prove that whenever n is odd, n cubed minus n is a multiple of 4. And we'll be using a direct proof. So it's going to be direct proof. And that basically means that we'll assume that n is an odd number. We'll do a few steps and eventually show that it's a multiple of 4. So part A, if n is odd, then we can write it n equals 2k plus 1, where k is a whole number. And now we're going to do the steps and hopefully end up with being a multiple of 4. So therefore, n cubed minus n equals, and we can replace n with 2k plus 1. So 2k plus 1 all cubed minus 2k plus 1. So we just need to expand this out, and I'm going to do this in the side. This is going to be a triple bracket, 2k plus 1. And we'll expand these, the last two. That's 4k squared plus 4k plus 1. And now we'll expand this. We'll multiply 2k first on everything to give us 8k cubed plus 8k squared plus 2k. Then we'll multiply the 1 on everything. So plus 4k squared plus 4k plus 1. And we'll collect like terms. So it's 8k cubed plus 12k squared plus 6k plus 1. Okay, so if we go back here, that equals 8k cubed plus 12k squared plus 6k plus 1. Then minus, and we can expand the bracket, so that's minus 2k minus 1. Let's do that. So equals, so we'll now simplify this. 8k cubed plus 12k squared plus 4k. And now, in order to show that something is a multiple of 4, we have to be able to factorize out a 4, and we can see that we can. There's a 4 on everything, so we can pull out the 4. Gives us 2k cubed plus 3k squared plus k, so therefore is a multiple of 4. And that's the direct proof. So just to recap, on a direct proof, you just assume what they're saying. So they said it's an odd number, so we let n be an odd number, and then just do some steps until you eventually end up with it being a multiple of 4. Okay, part B, we need to use a counterexample to show that this is not true in general. So we've proven that it's true for odd numbers, so presumably for some of the even numbers it's not true. And we just have to find one single example. So this is a trial and error bit. You just plug different values for n until we end up with an n that doesn't work, that's not a multiple of 4. So we can begin with n is 2, and if that doesn't work, we'll do 4, then 6, then 8. So let's let n be 2, and let's sub that in to n cubed minus n. Therefore, n cubed minus n equals 2 cubed minus 2, which is 8 minus 2 equals 6, which is not a multiple of 4, therefore is not a multiple of 4. Therefore, n equals 2 is a counterexample. And that's how you do counterexamples.